Good evening to everyone. I myself B.Nandhini. Today my topic is properties of linked list. Linked list. Linked list is a linear data structure where the elements are stored in continuous memory location. Elements are stored in the form of nodes and node contains data and pointer to the next node. There are different types of linked list. There are mainly four types of linked list: single linked list, double linked list, circular linked list, double circular linked list. In single linked list, the elements are stored in the form of nodes and each node contains data and pointer to the next node. In single linked list, last node contains the null pointer. Double linked list. Double linked list is a linked list where the elements are stored in a continuous memory location and it contains two pointers. Both forward and backward traversal is possible in double linked list. And the last node contains null pointer. In circular linked list, the elements are stored in continuous memory location and the last pointer does not contain null and it connects to the first node. Forward traversal only takes place. And unlike arrays, elements are stored in continuous memory location. Structure of a node. Each node has two parts: data and pointer. Pointer which shows the address of the next node. Example: data next, data next, and the last node contains null pointer. There are different properties for linked list like dynamic size, non-contagious memory. Let us know the importance of it. Dynamic size. Linked list are dynamic memory allocation. Size can increase or decrease during running time by using standard library functions like mlog, clog, reallog, free. No need to define size beforehand. Useful when memory requirements are unpredictable. Non-contagious memory. Nodes are stored at random memory locations connected using pointers. Efficient memory usage. No need for continuous memory blocks. Property 3. Efficient insertion and deletion. No shifting elements are required. Operations are faster compared to arrays. And in linked list, three operations can be performed: insertion, deletion, traversal, and searching merging also can be performed. Unlike arrays, we no need to shift the elements in the linked list. Insertion, deletion, traversal takes place easily when compared to the arrays. The time complexity of insertion is big often. The time complexity of deletion is big often. Property 4. Sequential access. Elements accessed one by one. Cannot directly access the element. Traversal required from the head node to the last node, which contains the null pointer for single linked list and double linked list, whereas in circular linked list, the null pointer will not be, and the last node which connects to the first node. The time complexity for searching is big O of n. Extra memory usage. Each node stores an additional pointer, requires more memory than arrays. Trade-off between flexibility and memory. As each node contains pointers, the memory is more required than arrays. For linked list, extra memory is required. Property 6. Flexible structure. There are mainly three types of linked list: single linked list, double linked list, circular linked list. Each type has different use cases. In single linked list, only forward traversal takes place. In double linked list, both forward and backward traversal takes place. In circular linked list, only forward traversal takes place. There is no null pointer and the last node connected to the first node. What is the difference between single linked list and circular linked list? In single linked list, the last node contains the null pointer, whereas the circular linked list, last node does not contain the null pointer and which connects to the first node. Property 7. No random access. No index based access like arrays. We no need to use array like index numbers, cannot directly jump to an element, requires traversal for every element. We cannot jump from one element to another element by using the while loop or for loop. We need to traverse the elements. Easy implementation. Linked list can be implemented by using stacks, queue, graphs, hash tables. What is meant by stack? Stack is also a linear data structure which follows LIFO principle where insertion and deletion both are done at the top side. Queue. Queue is also a linear data structure which follows the FIFO principle. FIFO means first in, first out, and insertion is done at the rear side, deletion is done at the front side. Insertion in queue is called NQ, deletion in queue is called DQ. Graphs is also a linear data structure, hash tables. What is the importance of head pointer? First node is called the head. The address to the first node comes from the head. Head contains only the pointer, no data, because the address for the first node comes from the head. Entire list is accessed through the head. Losing the head means losing the list. Property 10. Memory utilization. Memory allocated only when needed. Reduces wastage compared to arrays. Good for applications with unknown size. When memory is not required, we can free the memory. We can free the memory by using library function called free. Whenever we want extra memory, we can create the memory by using library function mllog by creating the nodes. Linked list versus arrays. What is the difference between linked list and arrays? In linked list, elements are arranged in non-contiguous memory location, whereas arrays elements are arranged in contiguous memory location. Linked list is a dynamic size. We can increase or decrease the memory as per our requirements, while array size is fixed. We cannot increase or decrease the memory size for the fixed value. And the linked list access, the time complexity is big O of n. Linked list access is slow, whereas in array accessing is very fast, big O of 1. Insertion, deletion and traversal can be done easily in linked list when compared to arrays. In arrays, insertion, deletion, traversal is difficult because we have to shift the elements, so it takes more time. Whereas in linked list, we no need to shift the elements because it contains nodes, and by creating the node by using mllog functions, we can adjust the pointers. So the insertion, all the operations such as insertion, deletion, traversal can be done easily in linked list when compared to arrays. What are the real life examples? Music playlist, next song pointer, train coaches connected together, browser history navigation, social media feed. Advantages: dynamic size, can grow or shrink easily by using the library functions. Efficient insertion and deletion can be done in a linked list without shifting any elements like in arrays. Better memory utilization, no pre-allocation. Useful for complex data structures like stack, queues, trees, graphs, hash tables, etc. What are the disadvantages of the linked list? No random access, must traverse sequentially. Extra memory required for pointers. As each node contains pointer, we need extra memory for the storage. Slower search operations. The time complexity is big O of n, more complex than arrays. The linked list operations are more complex when compared to arrays. Conclusion: linked lists are flexible and dynamic memory allocation, best for frequent insertions and deletions, slower access compared to arrays, widely used in real world applications. I hope you have understood the concept of linked list. Thank you.